Right, welcome back. Welcome back, right? It's been a long day, it's been a long break, but is this. Wait, what's going on here? There's something fundamentally wrong with, like, the way this looks. Wait a second. There you go, that's it. That's what we're talking about. Now it's fit. Okay, anyways, today we're gonna be doing, I guess, this. Yeah, I'm living in paradise, so don't worry about it. I'm really well. I'm really, really well. Anyways. Okay, this actually sounds interesting, right? So this sounds like a good problem, honestly. And we've had a lot of bad problems. So you can think of it, I guess, as some sort of a graph, right? So like taking the move of, right? I mean, if you're here and you're like facing forwards, you can only ever go here, and this incurs a cost of 1. But you can also like take this and incur a cost of 1,000. You essentially haven't moved your orientation, so you have your ij here and then your n, but here, I mean, this means you're facing north, but then here you have your ij and then you're facing, so let's say this is like a clockwise motion, so now you're facing, I guess, east, and then if you go here again, you incur a cost of 1,000, so this costs like ij, right? And then you're facing west, which is absolutely amazing, right? I guess. Um, yeah. Anyways, you could just go forward and go to like your I plus 1j, I guess. Right, and these are like your possible moves. These are like your neighbors, I guess, right? So a state is described by your ij and your d, which is your like orientation. So question is, can you run dijkstra on it? I hope, think, guess that you can. Um, the idea is you're sort of like exploring the state as you actually go forward, but it looks like dijkstra is possible. Okay, so I'll go make my coffee and then I'll come back here and we'll write a quick dijkstra for this one, right? I'll be back. I'll actually pause the movie, the film, whatever you call it in American. So welcome back, everybody. I have my coffee, but it's absolutely, it's like, it's got like 90 degrees on it. It's very hot. Just like my girlfriend. Okay. Um, yeah, so hopefully that should work. I mean, I have no idea if it would really work, but it sort of makes sense that it would, honestly. right? I mean, yeah, I guess we'll just run the extra, hope it works. Okay, so how does dijkstra look like? So from collections, I guess you need to import a heap. Like an IJ, and you have like a space, I guess, or like the cost to actually get there. You probably also need some sort of a distance vector, I guess. You actually don't. You can actually do it with just a visited set. So what do your nodes look like, right? Because your nodes look like I, J, and then D. So I guess D is inside of here. And this sort of means north, east, south, west. And you can do, right, if you do DERS, this is like north. What does north mean? It means sort of subtract from here. You don't change that. East means this, south means this, and then west means you go there, right? So and then essentially you're facing upwards, I guess. Oh no, you're facing east. So 1, 2, 3, 4, 5, 6. I guess this is the 7. So you do like 7. You do like 1, 2, 3, 4, 5, 6, 7. Yeah, so you start out facing east. So you start out with 1. Alright, so you do int through SI, SJ. And actually what you want to do is like, okay, what's the cost? Which is like that. And then SI, SJ. And then you want to go the direction that you're initially facing, which is like east. Then I still have a cube. You want to know this, I guess. Okay, I'm better off doing I is 13 and then j is 1. So I am pushing nd in here. I'm also always checking nd. I have no idea what I'm doing wrong. Okay, so what does this really mean? It sort of means, okay, I know, so I can actually figure out precisely what one of these paths may look like, right? And then sort of like keep going forward, and then you end up on your like end tile somewhere around here, right? This is your starting tile. But the idea is, okay, well, maybe there's another path. and it sort of looks like that, and then maybe, you know, it reunites with this one or doesn't necessarily, but whatever, we know that it goes off to an end tile. So what sort of property does this node over here respect? If, right, I mean, like, sort of that's the main question. What sort of property does this node respect? Well, I guess that the minimal distance from like your start node to this node, right? So I know this distance, right? And I'm interested in sort of if this equality over here checks out, right? Well, if I know if this equality checks out, then I know that there is a path from start to node, and then another path from node to end. So it's clear that there is a path from start to end that goes through me, and it sort of like reaches the end. And I know that its distance, its overall distance, is precisely the distance from start to end, which means I could probably run two dijkstras, and I'm interested of or in having sort of, okay, what's the distance? So I know that this over here also supports the property that this over here is the same as the distance from the end to the neighbor, like something like that. And this is the distance from start to neighbor. So I can run like dijkstra to know everything from end to neighbor, and dijkstra to know everything from start to some. This is not neighbor; it's just a random node, right? And okay, so I'm interested in sort of having state. So what does my state look like? Right, it looks like IGB, and then Why is this not true? That's a good question, right? Why is this not true? I mean, 11,036. Okay, so it's like smaller. But then, how come this one isn't smaller? Because the first time you like pop from there, right? What's going on here? So the first time you pop from the actual thing, then you get your minimal distance, right? And then get of IJD, right? That one should contain, it should always have the minimum distance towards it. So precisely the first time you drop, you pop out, this is false because they're equal, right? Now, if you may pop again and you get like some other distance, this should get you like over the actual thing. So what we're getting is that this one is smaller than that one. How does that even happen? Okay, I guess I'm just an idiot. Okay, what do we need now? We also need the not an idiot. sort of have to do it like the other way around, I guess. Because you do, okay, right? It's like you're like backtracking it. So maybe this trick will work, but I don't guarantee it will. It sort of does, if you reach it in the south, so south becomes. So S means north, which is 0, becomes south, which is 3, I guess. Plus 2, and then east becomes west, and then south, so it should be plus 2. P and B. And this is still trash, but wait, why doesn't my dijkstra work? I don't know. It's a good question, honestly. It's weird. Oh, we're just printing this, which is retarded. Gradient. Key error. I is 1, J is 15, D is 1, distance is 0. I is 1, J is 15, D is 1, distance is 0. One 15? How does D look like? Oh my god, dude. Wait, what? No way, man. Oh my god. The end. Okay, maybe this is because you need to do instead of, yeah, so one is where you actually make it out, I guess. It was like D and B. It's still two, which is weird. Mm. 3. So D and B is 2. Yeah. 0, 1, 2, 3. Right, so for actually 3, you're making it there. Yeah, which is this one minus 2, right? D and B minus 2. And then minus. Yeah, I don't know. 670? Okay, so we actually got the right answer. But yeah, so there is like one of them that actually goes through, right? That's what we care about. Yeah, so that goes through. So it's okay. This is actually an interesting way of doing it. Yeah. Anyways, this is quite fun, honestly, because you're essentially using this over here, but the way you're doing it is you sort of imagine, like, yeah, you kind of have to reverse the way you're walking and reverse your path in order to be able to reuse the same function. So that's like an interesting observation there. Because sort of the way, so what you're doing here is you're saying, okay, well, I can make it to like the end, and I don't know, let's say you can make it, like with a score of 13 or something like that, right? So this is your like end. And the way you got here is, let's say you got to your like end, which is your EI, EJ, I guess, and something like north, right? So you were facing north. What you're interested in from the end's perspective, so let's say that this is like where the end is over here, right? This is your end. There you go. Something like that. And you just made it here. So what are you interested, say, for general tiles, right? I mean, for this tile, what would you be interested in? Well, you'll be interested in actually the distance from here, right? From this particular graph node to this particular graph node. So this is what you want the end of, I don't know, let's say this one here is S1. The end of S1 should be the distance of this path right here, right? And what you're actually noticing is, okay, I've reached here looking north. Well, I could think, okay, how about I redo this path, but this time I sort of think of, okay, let's say I'm going downwards twice, and then I'm going to the left. Now you can see that this is sort of a different state from this one, S2, and precisely the way they differ is by -2 mod 4, sort of the direction, right? So if here I was facing east, here I'm facing west. Maybe there's a nice proof for it, but you can also see it sort of, I don't know, convince yourself that whenever you do a move, it's sort of the reverse move of this one, right? So each path in here, like this, has sort of a mirror in this way over here, as if we were starting from end. And this is the precise fact that I'm using in order to be able to do this over here, do d-2 mod 4 and then d there, right? I could also use d and d plus 2 mod 4 here because it's precisely the exact same thing, because we're essentially checking all these. Right, so we're checking all these and we're getting to 6, 7. Anyways, this is like the cute little trick that you can do, so you speed it up enormously, right? And then you sort of use, okay, so right now your d end, as if you are looking at S1, I'm still sort of checking out if this formula is correct over here. I'm not checking another formula, it's just this one, but I have to do this little trick because running dijkstra from here actually gives me different paths than this over here, right? I'm interested in these sorts of paths, but my d end at some ij d-2 d-2 mod 4 is what gives me these corresponding paths. If I don't use the d-2 mod 4, I get these paths and their difference, right? So what I'm trying to say is, okay, I'm interested in this path, and then this one over here is gonna be determined by, okay, so what's like the cost of going from here to here? That would be the start of ij and some d, like that, right? And I just know that if I want to use this path and know, okay, what's the distance from here to here, then it's precisely d-2 mod 4, because I have to sort of take the mirror of this over here, because if I used just d here, I would be referring to these sorts of paths. Anyways, pretty trick. That's it.